Hi everybody. So the next section we're going to look at is section 5.2, which is on the addition rule and complements related to probability. And so some of the objectives in this section then will be to use the addition rule for disjoint events. Those will be events that don't really have any overlapping connection. We'll use the general addition rule, and then we'll compute probability in an event using the complement rule. And so objective one then is to use the addition rule for disjoint events. So what it means for two events to be disjoint is that they have no outcomes in common. Another name for disjoint means they're mutually exclusive, right? So you can't have the same thing will happen in each event. Oftentimes we'll use pictures called Venn diagrams to represent events. So this would be two events that would be disjoint. So you have your sample space, which includes the numbers 0, 1, 2, 3, 4, 5, 6, 8, and 9. And let's say you have a dice labeled 0, 1, 2 on it, and a device and another dice with just an 8 and a 9 on it. Maybe this would be like a coin that you would flip, one side with an 8, one with a 9 on it. And so these events would be disjoint because you can't get the same numbers on the dice or the coin, right? So maybe you've got a 3-sided dice here and a coin with an 8 and 9 on one side. Now as far as the probability of getting an event E, well, you have 3 possible things that can happen out of a total of 10 numbers, 0 through 9. So the probability of getting something in event E, a 0, 1, or 2, would be about 30% or 0.3. And the probability of getting something in F, either flipping a coin and getting an 8 or 9, is about 2%. Now if you're talking about the probability of getting a 0, 1, 2, or an 8 and a 9, you would take the probability of getting E or F, which would mean you have 5 possible outcomes there out of 10, so that gives you 0.5 or 50%. So one thing to keep in mind here is that the probability of E plus the probability of F is equal to 0.05, which in this case happens to be equal to these two things. So we'll see that that will hold in general then is that the word OR implies addition, right? And we'll sometimes use the symbol union for that. And you can extend this rule to more than two things. So if you have several disjoint events, the important thing is that these events have to be disjoint, right? They can't have any outcomes in common. Then you can simply add the probability of each thing. So let's look at an example. So let's use this probability model to the right. And again, it is a probability model because all the probabilities are between 0 and 1. And if you add these all together, you'll get 1, which we'll do in step 1 here. But this is the number of rooms in a house or housing unit in this case, and this is the probability that you'll get one of these, right? So you can see that, you know, the greatest number houses typically then would have either 4 or 5 rooms in them, right? You don't see too many 1-room houses or 8-room houses, right? Or 9 or more. So again, this is a probability model, right? All the probabilities are between 0 and 1. I don't know if I'll have you do this on an exam. I'll probably just tell you that's a probability model. But and then if you add them together, you do get 1. So you might want to just verify that just to be sure. But I don't think they'll try to trick you on most of the problems. And then it'll ask you certain questions like, what is the probability a randomly selected housing unit has 2 or 3 rooms? Now, because these events are disjoint, you can't have a house with both 3 rooms and 2 rooms, right? I mean, if you don't include the 2 rooms as part of the 3, then these events would be disjoint, so all you'd have to do is add these probabilities together. Right? So the probability of 2 or 3 then would be 0.032 plus 0.093, which would give you 0.125. Let's ask another question here. What is the probability that a randomly selected housing unit has 1 or 2 or 3 rooms? Again, in this case, you just add 0.01 plus 0.032 plus 0.093, and that would just give you the answer. Again, because the events are disjoint, you can't have a house that has 1 room and 2 rooms and 3 rooms all at once, right? Again, if you don't include the 2 rooms inside the 3 rooms, etc. Right? So objective 2 here has to do with the general addition rule. And this is if you don't have disjoint events. So if two events are not disjoint, then you basically get this first part, or if they are disjoint, you get this first part. But if they're not just disjoint, you have to subtract the probability of the fact that you might have an event that's both in E and F. So as an example of that, let's say that you have a pair of dice are thrown. This is the possible sample space for all the possible outcomes, right? You can either get snake eyes, 2 1s, or you can get all the way up to 12, right? 2 12s. And let E be the event that the first die is a 2, and let F be that the sum of the dice is less than or equal to 5. Find the probability of E or F. Now, if these events were disjoint, you would just simply add them together. But in this case, that's not the case, right? Because you could have the sum of the dice is less than or equal to 5, and the first dice also be a 2. So if you count this, right, the probability of E then is 6 out of 36. So you can have 6 dice where the first dice is 2. That would be all the events in this row. And remember, it's just the first dice, so it's just this one that has to have a 2. And then the probability of F would be that you roll a 5 or less, right? So if you look at this, right, the total number of dice with a 5 on it, right, would be like this one, right? I mean, I think if you count them, there's a, I guess this would be another one up here. If you count them, there's a total of 10 of those, so that will give you 5 out of 18 if you reduce that fraction. And then lastly, if you look at the number of dice that have both the first dice as a 2 and that have a sum of 5 or less, you get 3 of those, right? So if you look back, right, there's you know, this has a sum of 4, right? This has a sum of you know, so this has a sum of 3 and this has a sum of 5, so these would be the 3 dice we're talking about, right? This has a sum of 6, so you wouldn't count that one. So according to the rule, because these events are not just disjoint, you would take the probability of E plus the probability of F minus the probability of E and F, which would give you a total of 13 out of 16. Okay, so just be aware that you can extend that rule for disjoint events to joint events, in which case you have to subtract the intersection, or where the two things overlap. So objective 3 then is to compute the probability of an event using what's known as the complement rule. And so the complement rule basically says that you're taking the opposite of an event. So if you know that, like, say there's a 40% chance that it's going to rain today, then the chance that it's not going to rain would be 100% minus 40% or 60%, right? That's all the complement rule says. The complement of an event is denoted by EC. So if you have an event E, then the complement will be EC. And basically, if you take E plus EC, it should equal 100%, right? It should equal all possible outcomes in the sample space. So basically, the probability of the complement of an event is equal to 1 or 100% minus the probability of event E. Like I said, if you have a 40% chance it's going to rain today, then the probability that it's not going to rain would just be 100% minus 60%, or 1 minus 0.4 to give you 60%, or 0.6. So let's look at an example of this. So let's say, so according to the American Veterinary Medical Association, right, 31.6% of American households own a dog. What is the probability the randomly selected household does not own a dog, right? Well, pretty easy using the complement rule. Just take 1 minus the 0.316, right? Just convert that to a decimal, and that gives you 0.684, right, which would be about 68.4%. To look at another example here, the data to the right represents the travel time to work for residents of Hartford County, Connecticut. Right? What is the probability that a randomly selected resident has a travel time of 90 or more minutes? So I guess what you could do in this case is you could, you could just go ahead and compute this, right? Take this divided by the total, so add these all up. I think you'll see that if you add them all together, you get this much. So just take the event here, this last column, and divide. That gives you about 0.015, or about 1.5%. Now, if you wanted to compute the complement of that, the hard way to do that would be to add all these together and then divide by the total. But what you can simply do in this case, if you want to calculate the complement, is just take 1 minus that probability, which will give you 0.985. Okay, well, I hope that gives you guys sort of a rough idea of what to do with that section. So if you have any questions or anything about that, let me know. The next section we're going to look at is 5.3 on independence and the multiplication rule. So we've looked at the addition rule for disjoint events, and what we're going to look at in the next section is the independence rule and multiplication rule. And sometimes people get these confused, so we'll kind of try to clarify the difference of these two things in the next section. All right, like I said, if you guys have questions, let me know.